Hi everybody, I'm Scott, and this is what is this? The smoke machine? No. Hi everybody, I'm Scott, and this is the SmokeNinja theatrical fog generator. It's a miniature smoke machine that you can hold in your hand and wave around, or put on a table and wave it around. I don't know. Point is, miniature smoke machine. This is, as it says, meant for theatrical use. They also pitch it for use in wedding photography, DJs, and that sort of thing. I don't know. Point is, I'm not going to be using it that way. I'm going to be using it to do two things. One, which is to show the beam dispersion patterns of LED lights and laser lights, certain other lights down here in the basement to make them visible on camera. Also, I'm right now in the middle of building a rack mount computer and using my own fans, and a fan in a place where there shouldn't be a fan, and a power supply that shouldn't be there. There should be a fan there instead. Point is, when this is all said and done, I want to see what the airflow is like within this chassis. My theory is put plexiglass on top of this to cover it, and then use a smoke machine on the intake side so we can see where the air flows with the help of maybe some oblique lights or a laser light, something. I haven't quite figured that out yet because I haven't done it yet, and I haven't even looked at this fog machine yet. So I'll be using this for a non-standard purpose, and I guess part of this is to see if it will work for that purpose, but also to show you what this is and how it works. Just a side note, this is not sponsored. I'm not affiliated with this company in any way.
I'll use my credit card.
That's how I got the product. Although I will say Amazon's advertising did work on me because this came up as a recommended product for me, and I was like, oh, actually, it's just boxes within boxes. Although, to be fair, this is a carrying case. Oh, it actually comes with a pretty big bottle of, well, they call it cloud formula. It's just, what is it, glycerin? Vegetable glycerin and propylene glycol. Yeah, kind of what you'd expect. So generally two things that are safe for humans. I mean, I wouldn't drink this stuff, but this is what they've been using for years in smoke machines. So if you've ever been to a club or a haunted house or some crap like that, you've probably breathed this in. And here's the unit itself. It also comes with a wireless remote control, which is RF, so you don't have to actually be in line of sight, which is great for theatrical purposes because you can presumably hide this in a prop or a piece of the set and activate it remotely. I like that. Not going to use it, well, might not use it for that. This, I guess, is the heater cartridge. Looks like it goes in up there. A magnetic mount. Oh, I see. A magnetic mount and a, looks like a 1/4-inch screw mount. Up here we got a warranty card, or at least the ability to register online, and a basic operating manual. And so here we got a USB fast charging cable and a cover, I guess, for the machine. Comes with 3 of these silicone bungs, which I'm guessing goes like that. And we've all seen a USB. It's A to C. So this thing does use USB-C for charging, which is great. I'm assuming it just has a non-user replaceable battery. And a couple of smoke shaping nozzles. So I'm supposing this is for what they call the dry ice effect, where this will act as a baffle to keep the fog from just shooting out the top. Instead, it'll sort of come out in a nebulous way. This has a much smaller aperture on the end, so that's probably for shooting out a thin beam of fog that travels farther, and a curved adapter, or I guess 2 curved adapters, so that you could shoot the smoke back into your own face. No, I'm kidding. I think it's a little more than a right angle when both are combined. But again, that'd be great if you need to hide this in a set or in a prop. You could then angle the smoke to come out wherever you want. And a little silicone cap. There probably should be 2 of these because I think it probably goes into these slots. And that is it. It comes with some directions on the back here with presumably a link to the instruction manual. So it says this top piece lifts off. There's a little catch there, so poof. There we go. Yeah, so this must be the heater cartridge. It also has the reservoir to hold the fluid. And that is threaded on the bottom, and it's threaded in there. Screw on like that. Slap that back on, and now the end of the heater cartridge is there, but we still need to fill the fluid. I don't want to do that yet because I don't want to risk it spilling out right now. And then it's also, see, I really like that. Is that an 18650? I'm pretty sure that's an 18650 lithium-ion battery. It's reasonably heavy, so it's probably at least halfway decent quality. It says 3,300 milliamp hours. Whether that's true or not, who knows. But it is great that it's user replaceable. So this way, if you need to run this thing all day, easily swap out the battery. And it did have a little tab in there to stop it from turning on. And is there anything under this? This should be the controls for it. Now, that label doesn't come off neatly. That's okay, though. And it's got fog, dry ice, and steam. We'll try those out, of course. And the USB charging hole. I hope this shipped with a charge. Usually they will, because it's not actually a good idea to leave lithium-ion batteries uncharged for a long period of time, for example, in storage. I don't have a USB-C cable handy, but let's just use the included one. Plug it in. Ooh, it just vibrated. That's cool. I'm not sure if it has a charge status indicator, but green has to be good, right? I guess that's really all there is to it for now. This is the fill port. And yes, I didn't know this came with such a large bottle of their cloud formula, as they call it, because I bought another one. I thought it was just going to come with like a little sampler size, but came with the same replacement size that I bought. That's okay, though. Can't have too much of this, because if you run out in the middle of doing something, then you're SOL. So the fill port on the top is pretty small, but these have a relatively small nozzle, so... Then I'm just kind of curious, does this actually seal that tight enough to keep it from... Yeah, it's airtight. I guess you could run it without this, but this probably gets extremely hot, so this is really to protect the user, and also, I suppose, provide an interface for these accoutrements. Let's put on the dry ice attachment, turn it on, dry ice, and then there's an activation button there, which I forgot to mention. Oh, it's making noise. Oh, yeah. Very cool. Yeah, that's a reasonably good effect. We can see which way the air is going in my basement. That way. You can go out on a limb and suppose that this would be steam. Oh, that's very fine, but it's high velocity. Yeah, you can see that. That's cool. What happens if I put it on dry ice setting with that nozzle attached? It's probably just a lower ejection... Yeah, it's definitely a lower ejection speed. Oh, maybe it gets hotter, too, because that's a lot more coming out. Let's do some over here so it goes across. That'd be good for, like, an old man yells at cloud meme. Because I could get a cloud next to my head. Well, if the air wasn't moving around so much. Yeah, I like that. And fog setting. Looks like a higher ejection velocity. Yeah. And of course, we can also just use this tube without the diffuser on it. We'll set it to fog. Set it to dry ice. Wait for this to clear a little bit. Neat. And steam. Well, I like it. Whether it'll work for my purposes or not, we'll see. Also, a little too much air movement down here for this to work for all of my purposes. But for the computer thing, should be okay. So, let's see. Let me turn it off. Actually, just don't hit the button by accident. Wait, there's 3 dots above the power LED. So, that means hit it 3 times, turn it off. Yep. Aha. Very intuitive. I like it. I mean, I didn't see that at first, but I like it. So, if we open the battery compartment, that sort of allows access to these two notches, which I guess is where the two mounts go in. Yeah. So yeah, that's the magnetic mount. Then this locks it into place. And you can stick it to whatever metal you want. They're not super strong, but they're strong enough to hold it. And same with the threaded mount. Oh, and I guess we should test out the remote. Yeah. And 3 button presses to turn it on. Which I didn't need to do the first time powered up, but that's okay. Let's just do dry ice. I think is my favorite. And then, oh, the remote I bet has a battery tab in it. Yep, to keep the battery from discharging in storage. Tends to, like on that first startup, I don't know if you saw that, it blew out a couple of droplets of the stuff before actually getting the fog going. Yeah. Oh, it's angry. Why is it angry? It's not empty. Oh, there we go. Well, neat. There you go. That is the device. That's the basics of how it works. Then, let's see how hot this is. Oh, it's not absurdly hot. It's just warm, actually. Yeah, and then I guess I would put it back in the cylinder for storage. I guess you could leave it in the machine, but in case it does leak out, you don't want it leaking into the machine. So you could throw it back in there. Which I believe was sealed pretty well. So there you have it. I forgot what it's called again. The SmokeNinja. From the company of... It doesn't say the company's name on here. It has their logo, but I can't read it. Weird. Ah. PMI. Practical Magic and Innovation. So if that's all you wanted to know, what's in the package, what it looks like when it blows smoke, what I look like when I blow smoke, that's what it is. I have one more test I want to run, which is not even a test of the machine, so if that's all you need to know, you can, from the video, that's all good. I'm just saying that to save time. If you want to stick around, please stick around. My concern is I want to blow this fluid in the form of vapor into a running computer. The question I need to answer is this conductive? Not the vapor, but the actual fluid. Because the thing is, this fluid will be vaporized by the machine, float around, and then it'll settle on surfaces. And if it's in a computer, it'll settle on the motherboard, it'll settle on PCIe slots, it'll settle into DIMM sockets, anywhere and everywhere. It'll get into the power supply. So if this stuff is even slightly conductive, I don't want to put it into the computer. So I want to test the conductivity, at least in a very basic way. And that's the next part of the video. Alright, so the bench is getting a little crowded here, but I got a Keysight multimeter here, which I'll show you in a moment, once we have something to measure. I also have a shot glass and a couple of wires with bare ends. The idea being that these wires are bent like this, and I'll arrange them so that they're about 1 centimeter apart, and they're at the very bottom of the glass. So I'm going to put some of this fluid in there, fill it up maybe about 1 centimeter in height. Doesn't really matter, I just need to cover both wires with the fluid, and then we're going to do some tests just to see what kind of electrical resistance this fluid has. I have a better one of these. This is an insulation tester, a real cheap one, but it will be able to spike up to 1,000 volts through this fluid, and we can see what the resistance is at that high voltage. First, we're going to use this Keysight multimeter, which is calibrated, and it's got Kelvin clips, which should read just about 0 ohms. And this meter can measure up to 100 mega ohms, which realistically, if this fluid has a resistance of over 100 mega ohms per approximate centimeter, I think it's going to be fine. It's not going to cause any short circuits in a computer. Connect one lead there, connect one lead there, and the wires are just about a centimeter apart in there. Approximately. I don't need to do this in a super scientific manner. I just want to make sure that the resistance isn't going to be super low. This stuff isn't super conductive. And you know what I mean, not in the sense of it being a superconductor. Alright, so the meter says overload, which means it can't measure it, so it's probably over 100 mega ohms or thereabouts. So what I'm going to do is move the probes in the fluid a little bit closer to each other. And we are getting a reading. Okay. It is able to read over 100 mega ohms, it's just not going to be accurate. And now the probes are about maybe a millimeter apart. And that's within measurement range of the meter. So yeah, they're moving slightly because my hands aren't, completely steady. But figure that's about a millimeter, maybe a millimeter and a half. And we're getting about 100 mega ohm. And that's a DC measurement. Next, I'm going to bring in an AC measurement, or a device capable of making an AC measurement. And first I'll set it to 100 hertz because that's the closest thing we have to 60 hertz on this, which would simulate if the fluid got into the power supply. So the leads are showing about 0.275 ohms. I got them back about a millimeter apart, maybe a millimeter and a half. And at 100 hertz, we're seeing 88 mega ohm. And if I take them a centimeter apart, I bet we don't get a measurement again. Oh, because this is capable of measuring up to 200 mega ohm. About a centimeter apart right now. And then if we take the frequency up to, let's say, a kilohertz, for example, how it might interact in a switch mode power supply, which might actually be a higher frequency than that. But now you can see the resistance drop down to 13-ish mega ohms. And again, that's with them about a centimeter and a half apart. If I move them more down to a millimeter, so that's about a millimeter right there, and we're at about 8 mega ohm. And then at an even higher frequency, should propagate even better. Yeah, now with that same distance, we're reading 200 kilo ohms. Yeah, that's not fantastic. And then finally, just to get a little crazy, and I'm actually using slightly dangerous clips here because they're not insulated by the tips. So the tip of the yellow wire is about a centimeter away from the blue wire. 500 volts. Yeah, I mean, it's fortunately getting the same reading in all the ranges, which makes sense. And at a centimeter apart, it's within like that 100-ish mega ohm range. Is it bubbling or anything? No. Okay, it's sort of stabilizing at 83 mega ohms. Now let me test the 500 for a little longer. Yeah, it's going down. I mean, maybe... electrolysis, like some of that metal could be dispersing into the fluid, making it more conductive the more I do this. Maybe. So 80-ish mega ohms at 250 to 1000 volts. That's good to know. Should be okay. Because also this is in a thick, continuous pile of fluid, which is not going to be the case if a little bit of vapor comes out of this thing and just gets stuck to components inside the computer. I think as I'm, a maverick, no, that's a little strong, but just because YOLO, I don't know what the right word is, I'll probably go for it anyway. So yeah, that's the thing. That's how much electrical breakdown or resistance you can expect from this fluid in fluid form. The vapor settling on crap, I mean, that kind of test would be a little more difficult because I'd have to get a sealed container, pump a bunch of this fluid in there, let it settle, and see what the resistances are around that container in certain points. Probably along the bottom mostly is where this would settle, but some on the side. Anyway, I'm not going to go that crazy. This satisfied my curiosity. Hopefully it satisfied yours if you were interested in a similar bit of information. So anyway, thanks for watching. I've been Scott. Stay tuned for more, I guess. Stay tuned. I guess stay tuned is like the old-timey version of subscribe, right? I guess I've been saying that for years. Like, you think like and subscribe is a new thing, but really television always used to tell you stay tuned. Radios too, like tune in at this time. It's kind of like subscribing. same sort of call to action anyway. So I guess we've been doing this for a century now, or more. Cool. Capitalism. Hey, without capitalism, I couldn't have bought this thing. So, ha! What are we even doing?
Détecteur de fumée che morì da Shiki o Yokeru ferma i densi Rauchmelder evitare i rilevatori di fumo avoid smoke avoid smoke avoid smoke detectors avoid smoke detectors avoid smoke detectors.
I don't know if this will make it better or worse, but let's see. Oh, shit. Alright, well, I didn't think it became that hazy down here, but I guess that proved two things. One, my smoke detector down here does work, and works quite well. Also, it's wired into the other smoke detectors in the house, and so the second thing we found out is that my wife doesn't wake up from a brief fire alarm. I mean, it only went off a few times because then the vapor dissipated,